Hi and welcome to 2014 Paper 2 Leave Cert Ordinary Level Question 6. So as usual I say, look, pause the video, give it a go and then come back to me. So I'm assuming you're back now. Now question 6 on Paper 2, there's a choice between questions. It's the only, Paper 1 doesn't have a choice, Paper 2 does. So you can do either 6A or 6B. I suggest doing both if that's something that you have time for, although most students don't do that in fairness, whether it's just a lack of time or lack of effort. And also the section 6B there can be quite tricky. It's usually something to do around the theorem or application of, where 6A is usually a construction, enlargement, or maybe a net or something along those lines. So it's much more doable, more popular among students. Let's get stuck in. Okay, so question 6A here to A part 1. It's worth 15 marks, okay, so you're asked to construct the in-circle of the triangle below, okay, and very important, show all construction lines. So you're working a good pencil, HB sharpened so the lines are clear. Don't rub them out in an effort to be neat, again, unless you make a mistake. Try to have a think about what you're going to do before you do it. You maybe even practice on one of the sheets, the extra work, just to get the idea of it. There's a fair few constructions. We've covered them before with links. I think it was in the 2016 Paper 1 or Paper 2, as links to videos. There's a math video here. I tried this earlier, and for some reason it's not working. But you may not need to watch video if you know them off by heart, okay? So, the first thing here is, you're looking for the in circle, so you need to know the in center. So the center is somewhere in here, and that center, when you draw a circle and you touch one of the sides, it should touch all three sides. Okay. Now to find the in center, you need to find the bisectors of the three angles. Now you actually only need two, okay, because once you've two lines meet, you have the point. So if I bisect angle A, I have it done on the next page, but if I take my compass point and put it at A and draw bisectors of equal length, okay, basically the arc there, so you could do the whole arc. Then take the compass point and put it at where the arc touches the line side AC, and draw another arc, do the same thing, putting the point of the compass here. I should get two arcs crossing. Now that point joined to the A gives me the angle bisector. Obviously I missed there, but you get the point, okay? So I'm going to go to the answer here. So you've seen the repeat of what I've done there. That's the arc, okay, where those two lines combine. They're doing the same thing here for bisecting the angle B. It's the exact same thing. You end up with the in-center. Now I could do C as well, but your C would just join up at the same place, so it's not necessary. I could have done bisected the angle here, A and C, A and B, or B and C. Depends on what you choose to do, okay? Draw your line in the circle in between. Now, if you're off by a little bit, it won't matter. But I would suggest to try to avoid that. I hate using the compass that comes with the math sets. If you know somebody, or if you do tech graphic yourself, you could borrow a good compass. They are worth the while, considering that they'd be very accurate. You may not be asked a question of a compass, so there is a level where going through the hassle can be just too much hassle. As long as you're within a certain amount, the idea to get across it here, and out of tolerance of measurement. Anyway, that's part A, part 1. Now part A, part 2, it's a 5 marker, 5B, so you have an attempt here. Measure the length of the radius of the circle construction in part B. Okay. Now, they're taking this line, I'm assuming this line here. But really, any line from the centre to the outside, so that line, if you measure that line there, it would be perfectly adequate too. I would try to make it obvious by writing on the measurement, so I got 3.6, writing on the measurement there. Even if your measurement was completely off for some reason, okay, by indicating you've measured a radius, you definitely get the attempt, okay. But I don't see why, if you know what you're doing, why it wouldn't be the full mark. Just be careful with everything that you're double checking your answer. Now that's question 6A, part B, A, part 2. Moving on now to part B. This is a bit trickier. There's only 5 marks going here, and an awful lot of work involved, but Let's read it out and see what happens. Otherwise, I suppose, even though we may have done already, if you haven't, now's a good time to pause this and have a think about it. I have a hint here, and it's something to do with Pythagoras, but we'll read the question and go into detail on that. Now, the point P is on the circle C with centre O and diameter MN. So let's see what's going on here. It's the point P. It's coming off the two ends of the diameter, M and N, and you have your centre Z there. So that should bring in mind the theorem that any point off the diameters gives a 90-degree angle. Okay, so once you know that, then this is a triangle here is a right angle triangle, which opens up Pythagoras' theorem as being a possibility. So I've written that here as a second hint. Let's go to the answer and work it out. So Pythagoras written out here. Okay, I'm told that the length of the radius is 2 square root of 5. Now that's the radius. Okay, so that's there. I'm looking for the hypotenuse of this triangle, which is twice the radius. That's why I have 2 times 2 square root of 5, which is the same as 4 square root of 5. Now my A value for Pythagoras' theorem is x, so it's not a number, but it's, I'm going to be working here in general terms. The value of B is 2x. If you look at it there, when I substitute the 3 values for H, A, and B, I'm going to be left with one unknown. An equation of one unknown is solvable, and that's what the final step will be. So I'm putting in the hypotenuse, side 1 and side 2. Going to do the maths of it now. If you're squaring this here, you square both the 4 and the square root of 5. So I've reflected that hopefully here. It's obvious. Okay, what I've done there. Now 4 squared is 16. Square root and square will cancel each other, so you're left with 5. 16 times 5 by my maths is 80. So I've took the left hand side there. Now the right hand side, x squared means x by x, which is x squared. That's easy. 2x we squared. Now, big mistake here, students write down the answer, 2x squared is the answer. They're forgetting that the 2 square applies to both the 2 and the x. So it's the equivalent of 2 squared times x squared. 2 squared is 4, x squared is x squared. So you're left then with plus 1 apple plus 4 apples, what's that? It's 5 apples. Okay, 1x squared plus 4x squared is equal to 5x squared. So here I am. Okay, I'm at this point here. You're now looking to go, well, that's an equation of one unknown. What should I do next? I don't see why you wouldn't try to solve it. You're looking for x, so solve it out. First thing we do is move the 5. The 5 was multiplied on the right hand side here. Goes across the left, becomes the opposite, it becomes divided. So 5 into 80 goes 16 times, so 16 equals x squared. Now I want to get rid of the square, so I bring it across the equal, turns into its opposite, which is square root of 16. Square root of 16 is 4. Now you don't have a negative here, it can't be negative because you're looking at lengths. So your value of x is 4 centimeters. Now that means this side here is 4, and this side here is 2 times 4 is 8. Okay, job done. Now I have the rule written down here that I'm applying up in this step here. Okay, so make sure you're familiar with the rules of powers. This is one that's just a little less commonly used than some of the other ones. Okay, so thanks for your time.